Hi everyone, sorry for technical difficulties. My name is Viktor Sitnik, I am a dcua team member, and today my friend Vladislav and I will present some task solutions we wanted to share with you guys. So let's jump directly to the tasks. The first tasks I want to talk about is Truth Insights from this year's NeoQuest calls. It was a forensics challenge and I know how every one of you like forensics. The task had brief description from which one could find the link to FLV codecs useful. There's supposed to be a video right here, but due to PDF, we'll skip it. After watching, there was just an Apple commercial. After watching the AVI file provided in the task description, we downloaded the original commercial from YouTube. There was an original file and that was provided. The first idea was to compare those files. To do that, we first split the given and original files into frames and compare them. Subtracting corresponding frames revealed interesting information on some slides. In the left corner, you see those marks. Seeing those marks, we found out that PET has something to do with it. PET is an esoteric language that executes programs using the colors and its shades as coding blocks. So we need to somehow make those differences colorful. Luckily, the number of those frames was exactly 24. And with 24 bits, you know we can encode any RGB color. Combining those red LSBs, we get this image. This image here. So the flag revealed that the code was that hash. Okay. Next task. Next task is from recent ACIS CTF. It's called NumberPy. Only 2 teams, I believe, solved that. It's 217 and mostly chicken. We were just given an image and some bits. There's not, there was some bits on top of the image. We wrote down firstly them and tried to convert them to something meaningful, but we didn't succeed in that. Then we thought maybe the image did matter. We see those bits on top of OS X hard drive image. I remembered that there was a file system based on pi number. To explain that, the idea is you can store any file inside pi, because number pi is a normal number, which means that pi's infinite sequence of digits in every base b is distributed uniformly, and each of b digits will always have the same density. In other words, no digit or combination of digits occurs more frequently than any other. And this is true whether the number is written in base 10, binary, or any other hexadecimal and other format. So having this property, number pi contains every finite sequence of numbers. To extract data, Bailey-Borwin-Plouffe formula is used. So this is PFS GitHub repository. You can download it and try it by yourself. So we composed the file from those bits on the image and prepend 2 zeros to the beginning to make it divisible by 8. And that then we transfer the file to PFS meta folder. After that, we mount the file system and just read the binary. That's all for me, and here comes Vladislav. Be careful.
Okay. Hello everyone. I am going to tell about 2 more tasks. The first one is secure house from new hack, recent quals, and its category is exploit, but I would classify it as web task despite not having usual website here because it's more about database exploitation. What we were given in the very beginning are secure house client pi, address of the server, and some description which looked like a hint but was actually misleading us. Well, what do you do with this? You obviously open up the code and analyze it. It was not obfuscated at all, and it was rather easy to analyze. What it was doing, it was communicating with the server, getting the challenge, and authenticating with username plus this hash. So there are 2 problems here possible. First one is that password hashing is done at client side, and that's really bad. But that's not useful right away. And the second one, we can try to inject it into database, but it did not look like an SQL-like database. So how do we detect an injection into such a database? Well, probably we can try to input special characters, everything you can imagine. So we did this as well, and on input line feed and to asterisk, we got protocol error, invalid multi-bulk lengths. And that obviously shows that the database behind this is Redis. We decided to use this multi-bulk syntax. Well, next on our, we were reading the docs for Redis because none of us knew how to work with it, and we invented this first terrible injection. It was working, but we could not read off any data from it. What we got from it is that we found out that there are no other commands but get and aus available, and no obvious flags in database like get flag, get key, and so on. We decided to change our approach. We refused from the syntax, and we tried to determine the command actually used to fetch the user. So we input line feed admin, and that leaked that the actual query was get username password. No, username name, sorry. Idea, we should try to get admin password from the database, and we just inputted admin column password and line feed. And well, we got welcome, some hash, we are verifying your password. Well, that's a hash of a password, obviously SHA-256. And here comes our first bug. We have caching done on client side, so we can simply use this hash and not even try to brute force the password. We send this as authentication data and we get the flag. And second task is Ghost Fuscator. It's from Volga CTF quals of this year, and it's about reverse and crypto. Files, we have 4 files in the bundle, and the description try to solve the riddle. Well, obviously we first open the files with code and we see evals in REST-Perl, and we should be really careful with them because we do not know whatever the eval can be evil up to removing your file system or whatever. So changes in REST-Perl without eval removal lead to CRC check fail, which means that there is some check on integrity inside the encrypted code. And if you remove the evals, decryption starts to work incorrectly. And that means that encryption is also done there. Well, we obviously started to gather some information. First, we looked up for ghost as is in task name, and we found some algorithm for that. And next, we looked for a Perl module because we have some GPM and we did not know what it is. So after Googling up this module, we have seen that its structure is quite alike to what we have in GPM. Well, there are two possible ideas here. We can write a custom decryption method for the code, but that's rather hard and time-consuming because we have encryption inside encrypted code. It's like decrypting some part of the code and it does something with encryption and works like that. And that would consume a lot of time, and we dropped this idea. We decided to analyze what GPM does, and that took about 1 hour. But it was rather fruitful because we found the decryption method, and the GPM was not checked for integrity for some reason. So we can just print the code right before it's executed. And what we can do next, we can just input random strings instead of the password it asks for and see what the check code does. And this makes the check fail, but gets the code printed. After we inputted some long string, more than 7 characters, it just printed out a huge piece of code for password checking, but inside there was a simple if that compared this is what you input to this complex password string. Everything else was probably junk to mislead people. And we now input the correct password, and it asks for an answer. And well, here comes the fun. There was some audio. There should have been some audio played when you get this question, but it did not play, and we could not download it. But we decided that it's not a big problem because we can see whatever it should receive as the answer later. Well, the next code compared the answer to any of the 4 strings after some regex replace, but we did not even start to analyze the regexes. We just tried the strings, whatever it might work. And it did work, and we got the flag. Thank you for your attention. Do you have any questions?
Are there any questions? No, okay, in that case, thank you for the lightning talk.